Now I have two vectors. I need to deal with these vectors by using their components. This is X and this is Y. I am in 11 right now. There's no questions, okay. I have S and I have H, right? S has an X component, this is S, it is 3, which is Sx, and the Y component of S, Sy, is 4. Who can tell me the components of H? I need to write S like this. S is equal to 3 in X direction plus 4 in Y direction. Should I, is it okay, the music? Live? Okay, who can tell me about H? This is H. How much the component for H in X and Y direction? Huh? Who can tell me about the components of H? Are they 4 and minus 4? Or if you see here, H starts from 2 in Y direction, ends with 4. In X direction, it starts from minus 2 to minus 4. So the components of H are not from 0. They are from here, from this point. If you move your H from here to here, you will see that the components of H are 2 in X direction and 2 in Y direction. But in X direction, we have the negative direction, so it is minus 2, right? How can another way to find them? It is solved in detail in the sheets. But for example, Sx is equal to Sx finally, which is this point, minus Sx initially, which is this point. And it is 3 minus 0, so it is 3. I take the difference between the starting and the ending point. Also here, I need to take the difference between the starting and the ending point. Now, I can draw my vectors in a different way. I can move H to this direction, to the origin. I can move H to the origin, keeping its length and its direction. So it is from positive 2 in Y direction and negative 2 in X direction. It is the same. What if I need to calculate? It is B and U. I'm sorry. This is B and this is U. So this is again. This is B and this is U. Okay. B, U. Right. What if I need to find S is equal to V as a vector plus U as a vector? Okay. I can find it by drawing. If I ask you, if you walk along V, then you walk along U. It's easy. This is V, which is the 3 and 4. Then I walk by U. This is V, this is U. From here to here, my resultant vector is this. The name of it is S. Find S. Okay, tell me. I start by V, then by U. I show you the PowerPoint yesterday, and you see that we can exchange them. But now we need to solve by put some numerical values, and it will be simple. You will see that. Yes, okay, simply. S is equal to V, which is Vx plus Vy in y direction, plus Ux plus Uy. We need to add the same component together. We need to add the x components together, so it will be equal to Vx plus Ux plus Vy plus Uy. Okay, it will be equal to Vx, it is 3. Vy, how much will Vy? You can tell me. Minus 2, yes, right. This is an x direction. Plus Vy, it is 4. Plus Uy, it is 2. In y direction. So this will be equal 1 in x direction plus 6 in y direction. This is simply Sx plus Sy. Just like that. If I ask you to find the direction of S, this is S, and this is theta for S. This is theta for S. Just by doing this, theta for S is equal to tan inverse for Sy over Sx. That's it. We will use it always and always and always. We will use this. These are our formulas. What if I ask you, what is the length of S? Okay, it is also simple. The last two simple steps is to find the length and the direction. I found the direction. The length of S is equal to Sx squared plus Sy squared and the square root. That's it. It is just numbers. They are just here. You can find them. You can see in page number 15. Any question about that, please? Online. Now, I told you from before, x and y direction. Sometimes we talk about them. It is to the north, to the east, to the right, to the left, to the upward, and so on. So we need a scientific notation to deal with them. We will not talk about any vector anymore as v is equal to vx and vy. We have a direction for Vx, it is in x direction, and we have a direction for Vy in y direction. So I will write them like this. For example, we have V. We don't need this. This is V. So we have V. As you remember, it is it is a 3 in x plus 4 in y. U, what are U? It is minus 2 in x plus 2 in y, right? Now we will not use x, y anymore because sometimes we have z. We don't have x, y always. We have t, velocity, and so on. In x direction, we will use the I in lowercase, the I with the hat on the top of it. With y direction, we will use j to tell us this is the y direction. If we have something in z direction, then we will put k. So we have I, j, k. I to the x direction, j to the y direction, k to the z direction. In our study, I think we will not deal with the z direction. The physics is the same. Also for you, it is -2 I hat plus 2 j hat plus 0 k hat. We don't have any component in z direction, right? So if we need to find r, what is r now? Simply, okay, we have I component for r plus j component of r plus k component of r, which is 0 as we know. What is the I component in r for r? Just add the x component as we did here. So it is 3 minus 2, which is 1. The y component, it is that. I did all of this just to explain and to discuss that with you if you have any questions. But simply it is just like that. And the length of r again, it is x component or rx. We can name it now rx plus ry. Square them under the square root. And theta for this vector r. Sometimes we have more than one vector. We have theta r, theta k, theta f, and so on. It is the tan inverse of ry over rx again and again. You can use the sine inverse or the cosine inverse. But if you are given I will tell you how this works. Assume that I gave you r is equal to 3 I hat plus 5 k hat. And I asked you to find the theta, the direction of r. We have tan inverse of ry rx. We have sine inverse to the length of r over ry. We have cosine inverse to the length of r over rx. Which one you will use directly? The first one, because you have them given. If any one of you will tell me, I will use the second, it's okay, but you have to find the length of r. You need to do another step. If you are in an exam and you are not required to find the length of r, so use this one. If you are given the length of r and any one of its components, then you can use the sine and cosine. Okay? Any question about that? Why?